Hello and welcome to this lesson on climate change. In today's lesson, we will define climate change and its key drivers. We will then examine the evidence supporting climate change. Finally, we will discuss the complexities of climate modeling and the scientific consensus on human contributions. Let's get started. Climate change refers to significant and lasting shifts in global or regional climate patterns, which include variations in temperature, precipitation, and the weather events over extended periods. Global warming, on the other hand, specifically refers to the increase in Earth's average surface temperature due to the buildup of greenhouse gases, GHGs, in the atmosphere. While global warming is a critical aspect of climate change, the latter encompasses a broader range of changes, including shifts in ecosystems, sea levels, and weather extremes. The vast majority of scientists and critics agree that global warming, and thus climate change, is occurring, even if they don't agree on its causes. Regardless, the result is a warming planet, which poses numerous environmental and societal challenges. The evidence for climate change is large and multifaceted. For example, historical temperature data reveal a consistent upward trend, particularly since the Industrial Revolution. Average global temperatures have risen by about 1.2 degrees Celsius since the late 19th century, a direct correlation with increasing levels of GHGs. We are also witnessing tangible effects of climate change, such as the melting of glaciers and polar ice caps, which contribute to rising sea levels. Additionally, there is an increase in extreme weather events, such as hurricanes, droughts, and heat waves, which align with predictions made by climate models. Furthermore, sophisticated climate models simulate Earth's climate system and allow scientists to predict future conditions. These models consistently show that the warming trends cannot be accounted for by natural factors alone, such as volcanic eruptions or solar variations. When human activities are included in these models, they align closely with observed warming over the past century. The potential effects of climate change are far-reaching and could include increased frequency of extreme weather. More intense hurricanes, longer droughts, and extreme heat waves could become more common, impacting agriculture, infrastructure, and public health. In addition, continued melting of ice caps and glaciers could lead to coastal flooding, displacing populations and threatening ecosystems. The biodiversity in these ecosystems can also be impacted by changes in climate, resulting in species extinctions and shifts in habitat ranges. For example, coral reefs are at risk due to ocean warming and acidification. Finally, altered weather patterns can affect agricultural yields, leading to food shortages and increased competition for water resources. Modeling climate change is inherently complex due to the vast number of interacting components within the Earth's climate system. Factors like atmospheric dynamics, ocean currents, and land surface changes all play a role. This interconnectedness can lead to unpredictable effects, making precise predictions difficult. Consequently, there is controversy regarding the extent of human influence versus natural variability, with some dissenting voices questioning the established scientific understanding. This controversy can create confusion and foster skepticism about climate science. Despite ongoing debates, there is a strong scientific consensus regarding human-induced climate change. An overwhelming majority of climate scientists agree that the rise in greenhouse gas emissions from human activities is the primary driver of current climate changes. This consensus is supported by numerous scientific organizations worldwide, which emphasize that immediate action is necessary to mitigate the impacts of climate change. Given the complexities and controversies in climate science, it is essential to critically evaluate the evidence and arguments presented in public discourse. Media reporting on climate change can sometimes sensationalize findings or selectively highlight certain aspects, leading to misinterpretations. This underscores the importance of seeking out reliable scientific sources and understanding the broader context of climate data, rather than relying solely on rhetorical claims. By fostering critical thinking, we can better navigate the complexities of climate change and advocate for informed action. Now let's look at some extension knowledge on the discovery of the connection between CO2 and the temperature of the atmosphere. CO2 is a gas that emits carbon dioxide, which is a
In 1896, I, Svante Arrhenius, had a monumental breakthrough. My work unraveled the connection between the Earth's temperature and the levels of carbon dioxide in the atmosphere. I discovered that if the percentage of CO2 in our air doubled, the Earth's surface temperature might rise by almost 5 degrees. Observing how coal fires were transforming cities, I couldn't ignore the evidence that our industrial habits were dangerously altering the atmosphere. Though my model lacked precision, my initial calculations would resonate with the scientific community in the future.
In today's lesson, we defined climate change and explored its key drivers, outlining the substantial evidence that supports its reality. We discussed the complexities involved in climate modeling and acknowledged the ongoing debate regarding human contributions. Nonetheless, we affirmed the scientific consensus on the impact of human activity on climate change. Finally, we highlighted the importance of evaluating evidence critically to form a well-rounded understanding of this urgent issue. Watch the rest of the GCSE chemistry course at Sophos Education.